calculate the cross-sectional area of a multiconductor cable according to the National Electrical Code, you simply add together the cross-sectional areas of the individual conductors as listed in NEC Chapter 9 tables. Common wire types used for multiconductor cables include THHN, THWN, XHHW, and XLPE. To calculate the fill area for multiconductor cabling in a ladder-tied cable tray, firstly determine the cross-sectional area of the cable. Calculate this cross-sectional area by adding the individual conductor areas together as mentioned before. Secondly, multiply this cross-sectional area by the number of multiconductor cables that are going to be placed in the tray. Thirdly, increase the total cross-sectional area by 60% to account for spacing between the cables and the general requirements for tray fill. This 60% accounts for the spacing between cables and the requirements outlined in the National Electrical Code regarding cable tray fill. The formula to calculate the fill area is fill area equals cable cross-sectional area multiplied by the number of cables, all multiplied by 1.6. The 1.6 represents the 60% increase that is achieved by adding 60% to 1, or by multiplying by 1.6. For example, if you have 10 multiconductor cables each with a cross-sectional area of 0.5 square inches, then the fill area would be calculated as follows. Fill area equals 0.5 square inches multiplied by 10, all multiplied by 1.6, giving a result of 8.0 square inches. This method will help in determining the correct cable tray size and ensure code compliance for cable installations. Cable trays are used to support and route cables. They offer an alternative to conduit systems. Cable trays are especially useful in situations where there are large quantities of cables or where changes and additions to the system are anticipated. The National Electrical Code provides guidelines on how to properly install and fill cable trays to ensure safety and reliability. The cross-sectional area of conductors is a critical factor in determining the allowable fill in a cable tray. The NEC specifies maximum fill percentages to prevent overheating and to allow for adequate ventilation. Using the correct cable types, such as THHN or THWN, is also important for ensuring the cable's insulation is suitable for the installation environment. The NEC tables in Chapter 9 provide the dimensions and cross-sectional areas of various types of conductors, which are essential for these calculations. Multiconductor cables consist of multiple insulated conductors enclosed within an overall jacket. These cables are commonly used in industrial and commercial applications for power, control, and signal circuits. When installing multiconductor cables in cable trays, it is important to follow the NEC guidelines to prevent damage to the cables and to ensure the safe operation of the electrical system. The fill area calculation ensures that the cable tray is not overloaded, which could lead to overheating and potential fire hazards. Also, consider dirting factors for conductor ampacity when multiple cables are installed in close proximity. Dirting reduces the allowable current carrying capacity of the conductors to prevent overheating. This is another key aspect of cable tray design and installation that must be considered to comply with the NEC. Always consult the latest edition of the National Electrical Code for the most up-to-date requirements and guidelines. The NEC is regularly updated to reflect changes in technology and best practices in electrical safety. In addition to the fill area calculation, other factors to consider when installing multiconductor cables and cable trays include the support spacing for the cable tray, the bonding and grounding requirements, and the proper methods for securing the cables to the tray. Support spacing should be in accordance with the manufacturer's recommendations and the NEC to prevent excessive sagging of the cable tray. Bonding and grounding are essential for providing a low impedance path for fault currents and for minimizing the risk of electrical shock. Cables should be properly secured to the cable tray using appropriate cable ties or other approved methods to prevent movement and to protect the cables from damage. When selecting multiconductor cables for a specific application, consider the voltage and current requirements of the circuit, the environmental conditions, and any applicable industry standards. Cables should be rated for the voltage and current levels of the circuit to ensure safe and reliable operation. The insulation should be suitable for the environmental conditions such as temperature, moisture, and exposure to chemicals. Certain industries may have specific standards for cable construction and performance that must be met. Properly calculating the fill area and following the NEC guidelines will help ensure safe and reliable cable installation. This is essential for the proper functioning of electrical systems in both industrial and commercial facilities. Using the correct methods and materials will help prevent costly downtime and ensure the safety of personnel. Always consult with a qualified electrical engineer or contractor to ensure that the cable tray system is designed and installed in accordance with all applicable codes and standards. They can provide valuable expertise and guidance to ensure a successful project. Remember to account for future expansion when designing a cable tray system. It is often more cost-effective to install a larger cable tray initially than to have to add additional trays later. Consider the long-term needs of the facility and design the cable tray system accordingly. Proper planning and design are essential for a successful cable tray installation. By following these guidelines, you can ensure a safe, reliable, and efficient electrical system. In summary, firstly, determine the cross-sectional area of each conductor in the multiconductor cable from the NEC Chapter 9 tables. Secondly, add the cross-sectional areas of all conductors in the cable to obtain the total cross-sectional area of the cable. Thirdly, multiply the cable cross-sectional area by the number of cables in the tray. Finally, multiply the result by 1.6 to account for the 60% fill requirement. This will give you the total fill area occupied by the cables in the tray. Always refer to the NEC for specific requirements and consult with a qualified electrician or engineer for complex installations. Remember that proper cable management and installation practices are crucial for maintaining a safe and efficient electrical system. Regularly inspect cable trays and cables for signs of damage or deterioration. Replace any damaged cables immediately to prevent potential hazards. Keep cable trays clean and free of debris to ensure proper ventilation and prevent overheating. Following these maintenance practices will help extend the life of the cable tray system and ensure its continued safe operation. In addition to the calculations and guidelines already mentioned, it is important to consider the type of cable tray being used. Ladder-type cable trays, which are mentioned in the original request, are a common type. However, there are also other types of cable trays such as ventilated trough cable trays, solid bottom cable trays, and wire mesh cable trays. Each type of cable tray has its own advantages and disadvantages, and the selection of the appropriate type will depend on the specific application. Ladder-type cable trays are often used for heavy-duty applications and where ventilation is important. Ventilated trough cable trays provide more support for the cables and are often used for instrumentation and control cables. Solid bottom cable trays offer the best protection for the cables but may require more frequent cleaning to prevent the buildup of debris. Wire mesh cable trays are lightweight and easy to install, but they may not be suitable for all types of cables. The choice of cable tray type will also affect the allowable fill percentage. The NEC specifies different fill percentages for different types of cable trays. Always consult the NEC to determine the appropriate fill percentage for the specific type of cable tray being used. When installing multiconductor cables and cable trays, it is important to avoid sharp bends in the cables. Sharp bends can damage the cable insulation and reduce the cable's current carrying capacity. Follow the manufacturer's recommendations for minimum bending radii. Use cable ties or other approved methods to support the cables and prevent them from sagging. Ensure that the cable ties are not too tight, as this can also damage the cable insulation. Label the cables clearly and accurately to facilitate future maintenance and troubleshooting. Use a permanent labeling system that will not fade or deteriorate over time. Keep accurate records of the cable tray system, including the cable types, sizes, and locations. This information will be invaluable for future maintenance and modifications. Consider using a cable management software program to track the cable tray system and its components. These programs can help to automate the fill calculations and ensure compliance with the NEC. Regularly review the cable tray system to identify any potential problems or areas for improvement. Implement a preventative maintenance program to ensure that the system remains in good condition. By following these best practices, you can ensure that your cable tray system is safe, reliable, and efficient. This will help to minimize downtime and reduce the risk of electrical hazards. Remember that a well-designed and properly installed cable tray system is an essential component of any modern electrical infrastructure. It is important to invest the time and resources necessary to ensure that the system is designed and installed correctly. When making any changes or modifications to the cable tray system, always consult with a qualified electrical engineer or contractor. They can help to ensure that the changes are made safely and in accordance with all applicable codes and standards. Document all changes to the cable tray system to maintain accurate records. Keep the documentation up to date and readily accessible. Train personnel on the proper operation and maintenance of the cable tray system. Ensure that they are aware of the potential hazards and the procedures for preventing accidents. Provide them with the necessary tools and equipment to perform their job safely and effectively. Conduct regular safety audits of the cable tray system to identify any potential hazards. Take corrective action to eliminate or mitigate the hazards. Foster a culture of safety and encourage employees to report any potential problems or concerns. By prioritizing safety, you can create a safer and more productive work environment. Remember that safety is everyone's responsibility. By working together, we can prevent accidents and injuries. The information provided in this narration is intended for general guidance only. It is not a substitute for professional engineering advice. Always consult with a qualified electrical engineer or contractor before making any decisions about your cable tray system. They can provide you with the specific advice and guidance that you need to ensure a safe and compliant installation.